whether 21, Tuesday the 21st, and around 11, right?
Yeah,
Yes.
I just had a
Sure.
quick question about the final presentation. You wanted to include everything, or just just updates from the last week, from the previous 2 weeks?
Well, it has to be everything.
Everything? Okay.
Yeah. So because I shared with you that the general guideline for the semester and the presentation format, and so you just revisit the guideline that I shared with you.
Mm-hmm.
Yeah. So just follow the guideline.
Okay, sure. Thank you.
Okay. All right. So let's get started with that.
And individual report. Okay. Yeah. Let me share my screen and we can get started. Okay. So the meeting summary for last time. I think we addressed all of the points, so we can jump into it.
Yeah.
One of the points you mentioned for here for the MQTT, you mentioned having the Raspberry Pi be the server and the phone can be the client. So just some clarification on that. So I mean, to start, MQTT is not a client and server protocol. It's a client and broker protocol. So
Okay. So
it's not as important to emphasize that. And then in relation to that, so just like an example of that. So if I'm sending commands through my phone, then at the time my phone
sorry, I
is,
think there's some echoes coming in.
Ibrahim, maybe on your side, can you mute your mic if you don't mind? Ibrahim?
Okay. Yeah. All right. Go ahead.
oh, sorry.
Okay,
Yeah,
so
so
MQTT
the,
is not the client server program, but just client
right,
broker.
client and
Okay.
broker,
Yeah.
right, absolutely. So if I'm sending something through my phone, so at the time of sending, it can be the client. If I'm sending a command through my phone through the UI that we build, it can be the client at that time. But then when I'm receiving, it switches roles in that time because it's client and broker. So
I see.
like any, right? And also to add to that point where you mentioned the Raspberry Pi can be the server. So Home Assistant is actually going to be our server for the MQTT protocol, and that's due to a few things. So MQTT is already extremely minimal, so there's no
Mm.
real reason to. And I remember last time I caused the confusion of saying. I need to have MQTT open on my MacBook. It needs to be running 24/7. The user needs it, but that's actually not true. I was wrong in saying that.
Okay.
So it can be done on the Home Assistant server, which we're already incorporating into our design. So the client doesn't need to go out and have a computer and have it open running 24/7. Um,
Mm.
so like as I wrote, Home Assistant will have MQTT and it's going to be minimal and invasive. So there's no and one of the bigger concerns we've been having is memory and how we're going to tackle that. So MQTT is already extremely small. That's not going to be a
Right.
problem at all. We can add that to the Home Assistant. And a great benefit of Home Assistant, and another reason we love it so much, it supports MQTT. So that's going to be extremely beneficial.
I see.
Um, After that, um, Hamza, I had the Excel sheet here. Do you want me to talk about this now, or
No, no, let's not talk about the Excel sheet yet.
I had one slide for the Excel? You're muted.
Or maybe Excel sheet next time. So let's talk about the circuit. Don't
Okay. I had one question about that. So I'll talk about it at the end. Okay. Okay. So we can move on to the circuit design.
Yeah, Professor. So I made this circuit using ESP32 and the three sensors I had, DHT11. On the left side, you can see the blue thing. That's a DHT11. And next to it,
What is that? What was it?
DHT11, the temperature and humidity sensor.
I see.
And the next to it, I just added an LED just to test ESP32 pins if they're working or not. And on the right side, on the third thing you can see in between is the LDR. That's what I use with the 100K resistor, and next to it I used the MQ2. So I tried testing these with the Home Assistant server. And
MQT is what is a acoustic
MQ2,
sensor?
MQ2, gas sensor.
Gas sensor. Okay,
Yeah.
I
So
see.
you can go on the next slide. So in the Home Assistant server, after I turned the ESP32 on and connected everything, the temperature I had in my room was about 76 Fahrenheit, and the humidity I had almost was about 35%. So for the LDR, we can see there's brightness. It shows like 2,704 volts. They it's supposed to show in like the luminance, but right now it's showing the raw values of A to D count, the analog to digital input counts. So I have to figure out a way to convert that to luminance or
Right. Yeah.
brightness. Yeah, that's what I'm still working on. And in the gas sensor, the same thing. I have to work on the parts per million. I have to convert the voltage to parts per million, the units for
Right.
the gas sensor.
Yeah.
So you can go to the next slide. So at first I tested the LDR by covering up the LDR itself I just covered up the whole thing, and I saw that the voltage, you can see the brightness went from 2,704 volts to 4,095 volts. So the resistance went up, the voltage went up. Why did the voltage went up? Because I think when you cover it up the LDR, the resistance goes very low. So instead the voltage goes up instead. So like I told you, I have to convert this to the brightness level instead of the voltage. So that's the thing.
That's a light sensor, right?
Yeah, LDR, yeah, light sensor, yeah. Can go to the next slide. So for the gas sensor, when I fed up with the lighter fuel, when I turned the lighter fuel without sparkling it, I fed the gas to the MQ2 sensor. Initially, it was. Can you go back if you don't mind? One slide back. Initially, the gas sensor had almost 1100 voltage over there. But can you go to the third slide again? Two more slide. Yeah, right here. So it turned into the 4095 volts, the full volts, after I fed the gas to the MQ2 sensor. So that meant the sensor is working. You can go to the next slide. So when I fed the MQ2 gas sensor too much gas, the green light turned on. Before, it was only just a red light. The green light meant like it's getting a massive amount of, the lighter fuel. So something, they should take an action, and turn on, watch if there's a gas leak or whatever. So that's how we tested the two sensors. I couldn't test the temperature one because
So
I didn't have
just a second.
any.
So this the MQ2 sensor is a gas sensor.
Yeah.
It looks like on the left hand side it's a red LED, isn't it?
Yeah, red LED. That's the initial.
So when the gas threshold, so you have to set certain threshold, I guess, right? Then this instead of green light, I think you got to turn on the red light. That's warning.
Okay, I'm
Yeah,
not
I mean
sure. I'm not sure how it works, but I think initially by itself the red light is always on all the time. So maybe we cannot change the settings or something like that.
So to look at that.
Okay,
Why?
I will look into that and I will update
So
you.
I think in the normal case you may not turn on the light, any light, right? And so I think you may consider maybe one threshold or two thresholds. So one, if it's normal range, maybe a green light, and but if it's a threshold goes over, then you turn on the red light, right?
Okay,
Or
I will look into it. Yeah.
even the you have to because in your home there is a gas sensor, right?
Right. The alarm actually, or
When
whatever.
when the gas level or somebody is like burning your cooking thing and it blows off. So I think that you may also consider to make it sound, alarm sound.
Okay, okay. I think I have some more sensors I bought.
Yeah, or you may just
So
buy the small speaker or something so that you can turn, you can blow that off. So you warn the people.
okay, okay. I will look into it and I will
Yeah,
update
yeah.
it. I will put it
I
on the
guess
circuit.
that the gas sensor might come with the
The alarm
audio.
audio.
Yes.
Okay, I have to check. I'm not sure.
Yeah, yeah.
I have to
Okay.
check.
So anyway, so that's and then if later on, I think this will be communicated with your cell phone, and the cell phone will,
Exactly. That's the whole point.
yeah, yeah. Okay. Yep. Go ahead.
Then I can go to the next slide. So in the Home Assistant, there was already uh, in the code for the sensors already there. So I just copied and pasted over here.
Yeah.
I used the code that was already there. And then I just had to figure out like the pins from ESP32, like which pin goes to which sensor. And so for that, I had to look into ESP32 datasheet and figure out the pins, like which one I have to use for that.
Yeah.
For the LED, I just use GPIO 17 on the. So for on the ESP32, it was like TX2 or something like that, the pin number. So there's a, it's not exact what it shows here. GPIO 17 is not, you cannot find it on the ESP32. You have to look into the data sheet and figure out which pin is GPIO 17. And same thing you have to do for the temperature and the gas one, also LDR. So that took me some time to figure out. I couldn't include I should have included the data sheet for ESP32.
But
The pins are.
I think normally you can design, right? You can connect to any one of the GPIO pin, and from the program level, you can control that particular pin to
Yes,
connect
some
to
of them
the.
didn't work for some reason. So
Why?
I don't know.
It should work. It
On the
should work.
no, for some reason
That's
they.
the idea of the GPIO. So you just whichever sensor that you have, whichever pin that you want to use, and you just designate that pin, and then you connect it, and then you control, just on and off control.
For some
Never.
reason on the code itself, it was showing that it's not compatible, something like that. So I had
Why is it not compatible?
I don't know.
So maybe
I just
the
had a hard
voltage
time.
operating level, the some sensors, the trigger level may not be triggered correctly by the output of the GPIO, because the GPIO, each pin has a certain voltage and current level, right?
Yeah, yeah.
And
So for the
current level
DH11, for
may
DH11, I
not.
use 5 volts, and
So what I'm saying is
yeah.
that so GPIO itself may not have enough current drive to drive all the sensors. So maybe you need to put like a small transistor or amplifier to amplify this power to drive one of the sensors. So
Okay. Yeah.
you may want to look at that.
But as you saw, ESP32 gives two types of voltage, 3 volts and 5 volts.
Okay.
So some of them I use the 5 volts for that. For DHC11, I use 5 volts. For
Okay.
LDR, I use the 3 volts. But for the MQ2, I use 5 volts again.
So you look
yeah.
at the
The
sensor
specification actually, for the.
right. Yeah, you gotta do that.
So
Not
yeah, it took me some time to figure it out. So that's the thing.
okay. Sure, you
Yeah.
should be able to do that. Okay.
Next slide. I think I'm done. Yeah.
Hi, Professor.
Yeah. Hi.
Yeah. Actually, this is the schematic of our board. So as you see here, it's like a enlarged picture. I would say there are many components on the board, so I think it's not like that clear. So I might go to my computer just and share, or it's okay if I talk here.
Can
It's
show.
up to you.
Mutawakkil, yeah, you can show. You can unshare, Wasim.
Yeah.
Go ahead.
Let me share mine. There we go. Yeah. So. Yeah. So this is the whole picture. Let me go to the next one. There we go. I'm gonna be starting from here. As you say, the relays at the bottom, as the last time, professor suggested that, you know, that the relays could remove to the edge of the board, and he
Right.
was suggesting that, you know, like we put some holes at the corner of the board. So that was such a good suggestion. So I made a mount surface, as you could see at the,
Yeah.
at each corner of the board, and you see like the relays are at the left corner and at the right corner, and actually last time it was all together, and mhm. So because what I did is here is basically move to the two parts, and there is less, as you say, like the spark. I mean, there is no. I mean, you know, that it prevents the sparks.
Right. Yeah.
Mm-hmm.
Well,
So,
at least, you know, we try to design, right? So to make
yeah.
this between that. Yeah.
So
Addition-
yes, as I say here, U3. What is U3? U3 is I squared C, and what is U2? It's a USB, and mhm. And you see all other components here, as you see here, MP2, LDR, and let me go to the next one. Yes, please. And here, as you see at the top left corner, SW1 is switch. Is like like it's a local switch. Like there are 4 of them, as you see here, 1, 2, 3, 4, and then here reset. And here is the LDR. So the LDR indicates, and it shows if it's on or off. And here is the galvanic isolation, as you see, like inputs, like 2 of them. And then, yeah, that's, and here is flash. So let me move on to the next one. Yeah, as you see here, the top one, home automation controller. And then, and the main part is here, ESP32. And ESP32 connects to the LDR here and connects to the flash. And as you see here, OLED, like the and DHT11. Mm-hmm.
So I'm sure that you consider the real form factor of the real devices, right? The LEDs and MQT sensors, and you consider all the size of the.
Yes, as I reconsider, yes, last time it was, as I said last time, it was not, you know, placed, it was not the last thing, last position. So, you know, and this is the last position that I have done it, and it's right here that I'm not gonna move it here and there, and this is the last version, I would say.
Design, okay.
Yeah.
Also, have you considered, so I see that some of the lines, connecting lines are very thin and some of the lines are a little bit thicker.
Okay.
So did you consider, for example, high current flowing? Then it's better to have a, you know, the wider the copper path. Did you consider current in this defining the path width?
I don't have a specific answer for this one. Then let me go and just do some more research, and then definitely next class.
Right, next meeting.
So yes, with the good answer.
So I think the routing must be okay. I think because you checked and all that, right?
I mean the routing
itself
yes,
is fine.
the last time.
But yeah. So within this routing, try to you know, for some line that carries you know, the higher current level, then you may try to, make the more wide path, right?
Yeah, definitely. And also as a logic, you would see as you said, like the wider line, it connects to the power.
Yeah,
This
that's for
indicates
sure.
this indicates that's the wider line because of the power, and the rest is just signal and other data.
Yeah. Okay,
So
that's the idea. Yes, the
yeah.
data is very thin, fine, right?
Yeah.
Mutawakil, are those thin lines for low current and thicker for higher current? I think so, right?
Yes. Yeah.
Yeah,
Yeah,
those.
so I think that
Yeah.
those path that goes to the sensors, right? Especially the relays should be
Right.
like a high current.
So yeah,
Yeah,
maybe those are for thicker. Yeah.
yeah,
Thicker.
yeah.
Yeah.
And the ground must be thicker as well, right? Ground.
Right.
Yep.
Yeah.
Let me go to the next one. I already mentioned this part. So this is like a DC power supply,
Mm.
and LD01 and LD02 is this one is like a 5 volt, and LD02 is 3.3 volt. It's just a regulator, power regulator. So let me go to the next one. Here, this is as you see here, like it states here, like bottom layer, and the bottom layer of our circuit, and indicates the relay drivers, and the green, the blue car, the bottom layer relay connections, the tracks carries the main voltage. As you see all of them, all the relays in blue color.
Very thick.
Very thick. Yep. This is.
Yeah.
So yeah, let me go to the next one.
Looks-
Here, and this is the complete board without ground plane. Right here, there's no ground plane here, and this one is a 2D
Oh, I
view.
see.
Yeah. And
Yeah.
then
At the moment, what is the size?
it's 10 by 10.
10
By 10
10 by 10 centimeters.
centimeter.
I see. 10 centimeter.
Yeah.
Yeah, it's good.
And this is 2D in the back side of our circuit. And as you see here, the danger and main voltage, is just all power is down here. And then here is the thing. This is the complete board with ground plane, not without plane. This one is with ground plane. And as you see here, just let me zoom in so you could see maybe better.
What is this like a grid type of thing? What is that represent?
Which one, Professor?
In addition to the path, right? The connecting path, but I see grid, for example, in the ESP32, the space, in the middle.
Here.
But yeah, the down there is a lot of grid, the red grid.
Oh yes, that's what I'm. That's what I'm about to talk about. That yes.
Oh, okay, okay, go ahead.
It's called like a chicken wire or chicken mesh.
This
is yes. That's why I was trying to zoom in so that you guys could see. This is a mesh. Yeah. So, what it does. So what it does. So let me go over it and just explain it. What it does. So it's
okay.
It's a shield ground plane that acts as a Faraday cage. What is Faraday?
I see.
Yeah. What is Faraday cage? Faraday cage it prevents electromagnetic synergy radiation.
That's right.
So that radiated from the internal components from skipping the cage. Where we could use it, of course, in any electronics, And of course, I use it in my project, especially in this circuit board. Yeah. What's the main reason to reduce noise? So as you see here, like it's again, I want to mention, it's look like a chicken wire. So
looks interesting. So
yeah,
one is,
from
the front layer and the bottom layer. Does it go bottom layer or upper layer?
it does. You see here, it does go to the bottom layer. You see here.
Bottom layer.
Yes, and then from R19, this is R19. From R19, what is it like? From R19, there below here there is no logic. Down here,
I see.
Yeah, there is no logic. So the logic that controls is this one, I square C U3 is this one inside it, shielded ground plane, the whole thing. This
So basically, it's the shield, the chicken wire is a ground, right? It's all ground.
It's grounded. Yep.
Basically, okay, yeah. I see that the ground is connected to the shield.
And then the bottom part, like here, yes, this is, as I said, there is no logic below R19. This part.
Okay. Okay.
Yeah. And all and then all here, as I said here, all signals are optically isolated.
I see.
So last time you suggested that, why don't you move your relay drivers to the edge of the board.
Yeah, just in case.
That was a really great idea. I really like that. Yeah, because usually most of the relay drivers are connected next to each other, but in our case, I mean, in this case, it seems perfect. Plus, it's very safe.
Okay. Hopefully. Yep.
Yeah.
So
I think let me maybe go back.
Go ahead.
This is how it looked like. And of course, it looks great. So here I put it here, CCNY Senior Design, and final year 2021. It looks amazing, isn't it?
It looks amazing. Okay.
Yes. So you see here, like this is
okay.
This is the this is mesh.
Yeah.
And call like a chicken wire.
Okay. Feathering your nest. Anyway, so the chip, right? Just go back to the last drawing. Yeah, here. So now you have how do you mount the chip?
Yeah, like you mean the ESP32?
Yeah, don't you have like a hole so that
no, actually what we does is like it's already according to the data sheet. So we're gonna be looking at the data sheet, and this is a prototype. And we're gonna be looking at the data sheet and just.
So is your plan to buy the ESP32 chip and mount and solder to this?
Yes. So that's like the one I showed you, ESP32. I have 5 of them. So that's what we're
what I'm saying is that, okay, what I'm asking is that, so this is a PCB. So the ESP32 have the chip legs, many legs, right?
Yes.
Yeah.
So we will take out from the ESP32 chip from the board itself. So now.
But how do you attach to this?
So we solder it. That's the thing. We will try to solder it.
So I was imagining that you have in this the PCB board you have a like a hole, so that
there's no holes in it. There's tracks on it. So we will try
the tracks in it.
Yeah, we'll try to solder it on the tracks. So that's
you see here, Professor. Like every track is like well designed here, and then all the pins is gonna go to those like it's connected to the tracks.
Yep.
And yeah, we're gonna be it dedicates too much time to mount on the board.
Well, because I don't have experience. I have experience of soldering this the gates here, but at the time they have a hole, so the the pin
Like-
here, and then you just plug in and then solder it. But this one, I don't know. I don't know. Do you understand what I'm saying?
Professor, on the right side, let's see for the sensors, right? You can see there's holes for it. DHT11 on the right side, bottom, like down.
Yeah. So this
So
is
DHT11
that
MQ2, there's holes for that. So I think for ESP32,
all these are holes, right?
yeah, these
Yeah,
are holes like the
but-
circles.
so like these are holes, as you say, like we could, just put the components on the board and just solder
Yes.
it, right?
Yeah.
Yeah.
And
So the
with
same
this
thing.
one-
Don't you have the same thing on the chip? At the chip side?
You mean the ESP32?
Yes. For example. And
No,
also, for example, you
we don't need,
two.
Professor. We don't need like holes for the ESP32. And according to the data sheet, we're gonna be looking at the data sheet, and it's already. I already took a look, and that's how I designed this one. Is like it's precise, so we could mount on the top of the PCB.
So, for example, the U1, right? U1 is a
Right.
32, and then there is a copper the array here. So the chip just sitting on top of this, and then you solder it, right? How? Because so the for example U2 and U3. U2 is a USB. I don't know.
No, I2C.
No, I square C.
Okay,
Yeah.
so those things normally, right? Normally, if you look at that, they have a pin, and then there's a hole, and then you just plug this chip into the hole first, and then you flip it, and then from the back you solder. I think that's normally what happens.
Ibrahim, do you have the 3D render? Can we maybe we can see clearly on
Yeah.
that, maybe.
So can you show me the
The
like
3D version, I think maybe it's
Yes.
So what happened is like
yeah.
So in this case, no, I don't have it here, but I could get it. Not a big deal.
Okay.
So, so what happened is like.
What I'm asking is that because I don't have experience of this large pin chips, so I don't know so I imagine that all the IC chips have the pins, output
Right. But as you see here, yeah, I got your question.
Yeah,
I
but
mean,
the relays,
like,
yes, relays you have holes. That's very good. But
then,
doesn't this the chip place this ESP32 or U2 and U3
Professor,
also have to have a pins? I mean holes.
According to the data sheet, you could get the two different types of chips.
I see.
The one has the, as you said, the surface. It's called like surface on mounting. Surface mounting, which means you just take it and just plug it there. Second, and it has as you see like pens, so you could, as you see here, and you could put it like for other components, so you could just plug in and just solder. For in this case, it's just called surface mounting. Means you don't need pens here.
I see.
Yeah.
How the soldering can be done?
So I have done soldering. I'm good at it, and then of course I'm gonna be asking help from CCNY professionals. Maybe it's called like
there's lab technicians, so we're gonna get help too.
Space maker.
Yeah.
I would love to be neat and clean.
I see.
To do this board, yeah.
Okay, so it's because my experience is stop there because I don't have any experience of this thing on the surface mounting. I don't. But okay. So as far as it works, that's fine.
Sure. And then you see like it has a mounting place here.
Okay.
on all four corners.
Yeah, that's very nice. Yeah.
Yeah. Thank you, Professor.
Okay. Yeah,
Really
looks
appreciate
very
it.
good. You must be.
Yeah.
But by the way, so this software, does it automatically check whether there is some misrouting and something?
It does actually. As you said
I
last
see.
time, I really appreciate your opinion. So what happened is like auto routing is just not perfect. It's not always, it's going to give you 100% clearance. So what I did is like, it's going to give you some percentage, but you got to do it. It dedicates so much time that you could do it manually.
So
That's the
just
whole.
follow all the tracks or all the
Yeah,
traces.
follow
Okay.
tracks. Yep.
Okay, good. All right. Thank you.
Yeah, you're welcome.
Yeah. Okay. So move on.
Hello, Professor.
Yeah.
So I got a camera in last Tuesday evening, and I tested something in from the Raspberry Pi is to like take some picture. So but the thing is, I just show you like my okay, just screen. Okay, you can see my screen, right?
Yes.
So so if I do this, okay. So I create a folder for face recognition. So I go to the folder. If I go to the folder, um, okay. So this folder I have okay. So that folder I have a
Face recognition. Yeah.
yeah. So that folder I have like a data sheet. So I create a folder, another folder for data sheet for like the keep my all data and keep my all. So if I go this folder, okay, you can see my name here.
Right.
Hassan.
Okay.
So here, so Hassan. So I here.
You take your face and store
Yeah,
there, right?
yeah.
Okay.
So yeah, I take my face. So there's some picture I have here. I couldn't. I'm not gonna because it's very hard to see my computer because I have like another computer to attach my Raspberry Pi there. So so I took like almost 13 picture, and I try to train this picture, but this take too long. This too slow to the thing, and for that I write a code. That code is I'm going to show you now. Okay, so this is the code. Okay, so this is the code I write it. So I import a CB2. This is my name here, and the camera is CB2 video capture. And this thing is like when you just run this code. So I press the space key. So when I press like one space key, it's gonna take it like one picture, and I take like another space key. If I take this keep pressing the space key, it take me like a lot of picture. And I last time yesterday I took like almost like 250 picture, and I tried to train this. It's gonna take like 4 hours to complete this model.
Oh.
So it's too slow, and then I think like this is the best way, because I don't know how much picture is efficient for this face recognition, and I need to figure out.
Just a second. So for this part, I think you can use your computer, right? And just upload your processed image into this Raspberry Pi later on. instead of Raspberry Pi doing this all the compression and do the stuff.
Yeah, I mean, yeah,
You can do the offline.
Yeah, I think about that. So I need to, in that case, I need to upload it. I mean, yeah, download OpenSIP in my computer, and I'm trained from there.
Yeah. So usually, I think usually that's the case. You know, all the hard, in general principle that even the base station, the cell phone base stations, doing all the heavy lifting, right? The phone cannot do everything. For example, the Google Map, actually, all the routing calculation is done at the Google server, and then the result will be presented in your cell phone. Your cell phone doesn't process it. Likewise, so all the you gotta do the like
you got a good point. Yeah, sure.
Yeah,
because
and also another comment is that when you take the picture, you have a different illumination.
Yes.
You face different angles so that
that's true.
Detection ratio should be higher.
Yeah, that's true. Yeah.
Okay.
And so yeah, so I don't think so. I need to further like explain this because this thing is like I mean. Yeah, I mean, if it is like don't grab the frame, is going to break and then it's come again. So yeah, this part is like for like taking a picture. I mean, this code is like taking all like the picture.
Yeah.
So and then from there I have like so I have like another folder right here. If I okay, so I have this folder. I need to write the code for this. That this the like the main main folder for the face recognition is going to be like detect your face to open the door or something like that. I need to write this code for this folder, and also this thing I already wrote it. The face shot. I take a picture from this, and the higher cascade this thing. Yeah, I need to modify this thing for this, and the train model I need to also write a code for this folder. So so yeah, I'm going to maybe next week I have some like update for this two thing. So I'm going to
maybe I think I like you to do like maybe some maybe not only your face but also maybe other other people, your team members, right? Yeah,
of course I'll do
at
that.
At least your team member of pictures have to be taken and store it and show the demo.
Yeah, Professor, we will send him the pictures.
Some time.
And then next week I will like I'll try to download this thing OpenSIP in my computer, and then from there I will like give you.
That's
some
right.
updates.
Yes.
Okay.
Yes. Okay.
Right, Professor. So so this is my demonstration today. So
good. Yep. So you made a.
You should add some of this on the presentation if you don't mind. Yeah.
Well, yeah, because
pictures of
I'll do that because I use different computers. So this computer is I only use for the Raspberry Pi, and then this computer is, I mean, I know the Raspberry Pi is like too slow, and if I open another folder or something like that, is running too slow.
Yeah. Okay.
And this is very hard to transfer this this thing folder to one computer to another computer. So yeah, and if I add like VPN or something like that in my computer from this, so I can able to open this Raspberry Pi in my computer. But this VPN thing is a little bit like the secure stuff, something like that. So sometimes it doesn't work for my end. So I don't know, it's like the internet connection or something like that. So yeah. So yeah, so next week I'll give you like more update about this, and yeah. Thank you, Professor.
Good. All right.
Yeah, I think that concludes our presentation. Yeah.
Okay. Yep. All right. So
one comment about the budget.
Share that. Okay.
Do you see it?
Yep, I see that.
Okay. I mean, currently with like our projections, we're gonna have around 403 spent, but
Does this include the estimate for the PCB boards?
so it is like things that we haven't ordered yet, but it is.
I think
So
you have to save the budget for this PCB.
yeah, so I think before that, so the stuff for the PCB is something around like 112, like all the components that we're thinking of. But I mean, the main question that like I wanted to ask, so it's about 96 left. But if we run into a space issue, which may happen with the Raspberry Pi and OpenCV, I just wanted to like ask your input. Does it make sense to buy another Raspberry Pi?
I think okay, so I can give you Raspberry Pi. I have a couple in my office, so I think you may want to use it just in case if you need it.
Okay.
I think we're gonna meet in the school, so you can come to my office and I will have them available to you.
Okay, that's perfect. Yeah.
Okay, so go back to the budget sheet. So that 408, does it include this the board estimate? 112?
Professor, it's not final yet. I have to still do more.
Yeah, this is our
research,
projected.
because I have to work with Ibrahim and to figure out like which components we need to buy yet. So 408 is basically the parts we have to buy for the whole PCB. So so we did buy, because we can't buy only like one or two things for PCB, right? So they give us like 1500 pieces or 100 pieces, then we have to buy for that amount, so that's why the budget, it took a lot of amount. That's why it's 403. You see, for like just for like, let's say terminal block or something like that, 20 pieces, they charge us $9 for that. So it's the same thing if you continue for each part, like it's the price is very high. So that's why I think as of now I think we'll be having about $100 left behind. So
I see.
yeah, we still have to do more research because I haven't bought this component yet. I just made a list. So I just made a list so far, so it's in the cart.
So
I didn't make the purchase yet. So
okay.
it just
At the moment, so you are saying that you may need a Raspberry Pi. This is, I think, 110 is a upscale version, isn't it?
It's the 4 gigabytes version, I think. So
Yeah. So,
yeah,
I
so
think,
if it's running slow, then we need maybe the 8 gigabytes. That's about like 100.
I don't think, I don't think the 4 gigabyte would really cut it, because like it's not about it not having enough space. It's about it running like very,
doing the
very
processing
slow.
power, yeah.
well,
Professor, I think we did.
anyway, so
we
I
didn't
think
mention with you. I think
a little bit of slower demonstration is okay. I mean, this is a proof of concept thing, not really production stuff. So the slow, being slow is not a really big problem.
Okay.
Professor, I think you mentioned in the previous meetings, you said Raspberry Pi can handle most of the stuff easily, but now we're having trouble. I don't know. So
It's not.
yeah. I don't
So
know.
now you have a
that's how you mentioned.
ESP.
Then Raspberry Pi can take the server too as well, like all the other things. Like I don't know. I think the Raspberry Pi cannot handle.
Try it, and then also you have a ESP32 as well.
So yeah, we will try to do that.
Yeah, try to
I think as you
make
were
use
saying
of it.
that Raspberry Pi can handle everything. So if it's stuck at one task, then I don't know.
Not specifically. I don't know. I mean, especially I think this OpenCV thing take up a lot of resources from the Raspberry Pi, and how much the processing is left for the tasks, not sure. So just in case if you need one more Raspberry Pi or I think that will be fine. I mean, you can.
Okay, we'll be in touch with you.
Yeah. Also, I can give you one.
Okay, sure. Yeah. Thank you for that. Yeah.
Yeah, that's perfect. Thank you, Bros.
Okay.
Any other comments, Professor?
Just wrapping up for this the final presentation in 2 weeks, and and also let me know that if the Professor schedule is Zoom meeting, and also I will ask him to join our presentation as well. Okay.
Professor, I think I have one more question. What individual reports? When do you want it by? What is the due date for individual reports?
So I said it. I think
The same day as the presentation.
So look at your guideline. I think again. Let me see. Just a second.
Okay.
So 421. No, this. Yeah, I think I should have given you that one as a project. Let me see.
Are you talking about this, Professor, the project proposal guidelines?
Yeah.
Well,
So that's
it doesn't mention anything about the final report or any
deadline.
date.
Yeah.
Well, I mean, it doesn't mention the report either.
Yep.
Okay, I will revise it. I will send it to you. Okay.
Okay.
Yeah.
And then was there a date that you were thinking as well?
Yeah, usually I think after the presentation, maybe a week. But I think there is also some great deadline. So so while you are preparing, I think the general guideline is already there. But I think except maybe the date. Let me see.
For the presentation, I mean, for the final presentation, there's no real guideline here.
No, I have it here. So let me just send it out right to you.
Okay.
Yeah. And then, so let me see, since our presentation 21, maybe Christmas Eve.
Okay.
Oh, the reports?
Yeah.
Okay, yeah, that works with us.
Yeah.
That gives
So,
us plenty
okay,
of
so I
time.
will,
Yeah.
with that, the due date, I will send it out for the final presentation. Okay.
Okay.
So Professor, it's going to be only a presentation, right? Final one.
I think the report as well. So
presentation and the report, Ibrahim. But
yeah. So that's, I think, both of them.
I see.
Okay. All right. Yeah. You and hope to see you in 2 weeks, right? And then just confirm the time that you can come on 20th in the morning, like 11, right?
The 21st, right?
21st,
The 20th.
yes.
Okay.
Tuesday, that's
yes, that's the 21st. Yep.
21st, yes. Okay. So at the moment, then I think it will set
11 o'clock as of now.
11 o'clock. Yeah, at school, right? Yeah. Okay.
Oh, you want it to be in person for the final presentation?
Yeah.
Yeah.
For you too?
That's
okay.
that's what we're gonna meet at school.
Okay. I will let you know.
But so you know the guideline, right? The COVID guideline. You have to do a cleared for. I will send you the guideline.
First, this thing, or how does this work? They just recently launched it, I think, right?
So it's recently the new the guideline. I did it. It's very simple. On the cell phone you just do it, and the vaccine information or something, and then there is an app.
So we just need to upload the vaccine record. That's it, right?
So
yeah, I'm not sure. I will have to check.
Because our web
we'll
page, CCNY web page, the front page also.
I think I did get an email from them. Everybody gets an email for them.
Yeah, you guys must have got email from the president or something, right?
Because I think I don't know. They was doing random testing too. I think of students.
That's another thing.
So you see, that's I don't know who's gonna get caught.
So that's a random one. So actually, I gathered that one of our faculty called upon, and he just had to go and they get tested.
And it's like you can't even use outside resources. I think it has to be some CCNY testing site or something like that. So they limit you to very crazy option. So yeah, I don't
Well,
know.
I don't know. I mean, I don't
So
know
I think
how.
some students was
Works.
having problems with that. So yeah.
Oh, I
I don't know.
see. Okay.
So
But anyway, so I think unless you are called upon to test yourself, but I think the rest of it is a pretty straightforward. The getting that much more clear for pass, right?
okay.
Okay.
Okay,
All
we'll
right.
see you in
Thank
2
you,
weeks.
guys.
Yeah.
And
Thank you.
then see you in 2 weeks.
Thank
Okay.
you for your time.
Bye.
Thank you,
Bye.
Professor.
Bye. Yeah. See you.